Now let's balance redox equations or redox reactions. Let's look at 1.1, and here we have lead oxide reacts with a chloride ion, and that gives us a lead ion and chlorine. Now the first step is to find the half reaction. The first half reaction is lead oxide and the lead ion, and the second half reaction is the chloride and the chlorine. So I'll just write that down for a moment. Now the next step is to find out which half reaction is the oxidation reaction and which is the reduction reaction. There are two ways we can determine this, but I'll show you the first way, and that is to assign the oxidation numbers. So let's first start with lead oxide. So as you can see, the overall charge of lead oxide is 0. And we also know that the oxidation state of oxygen is generally -2. And keep in mind that we have 2 molecules of oxygen here. So let us set up the equation and solve for lead, solve for X. So X plus 2 molecules of oxygen multiplied by -2, that is the oxidation state of each oxygen molecule. And now let us simplify and just solve for X. And in the end we get X as +4. So the oxidation state of lead in this compound is +4. Now on the other side of the reaction, lead has an overall charge of +2. So that means that lead must have gained electrons during the reaction, because remember, electrons are negatively charged. So if you would express it in a mathematical way, it would be 4 minus 2, you put in negative electrons, so that will give us a charge of 2, +2. I hope that made sense. And now remember that reduction happens when a chemical species gains electrons. So that automatically means that this half reaction is a reduction reaction, because lead oxide gains electrons during the reaction. Now this automatically means that the other half reaction is the oxidation reaction. But for demonstration purposes, I shall show you, I shall prove it to you that this is an oxidation reaction. So we have chloride, a chloride ion, and that turns into chlorine. So chloride has a charge of -1, and chlorine has an overall charge of 0. So this means that the chloride ion has lost an electron, because we're going from a negative to an overall charge of 0. You can think of it in a funny way, and that is the chloride has lost some negativity and it is happier now because it has lost that electron. Now the next step is to balance the half reactions. So let's start with the first half reaction, that is lead oxide. Now let us check that all of the atoms other than hydrogen and oxygen are balanced. Well, we have lead, and that is balanced. We have 1 lead on the left side and 1 on the other side, so that's balanced. The next step is to balance the oxygen, and we balance it by adding water molecules. So we have 2 on the left and we have 0 on the right. So this means that we need to add 2 molecules of water to the right side of the equation. However, now we have introduced a new molecule, and that is hydrogen. So we have 4 hydrogens on the right side, because 2 multiplied by 2 is 4. But we have no hydrogens on the left side, so we need to balance it by adding hydrogen, or by adding protons. So since we have 4 on the right side of the equation, we need to add an additional 4 protons on the left side of the equation. The next step is to balance the charge of both sides of the equation. So as you can see on the right side, we have a charge of +2, and on the left side we have a charge of +4. Now we balance the charges by adding electrons, and remember that electrons are negatively charged. So how can we get the charges to be the same on both sides of the equation? Well, we can add 2 electrons on the left side of the equation. So if you were to express this in mathematical terms, it would be 4 minus the 2 electrons, and that would give us a charge of +2, and that matches the charge on the right side of the equation. So now the charges have been balanced. Now I would like to mention one small thing. From this balanced equation, you can tell whether it is an oxidation or reduction reaction. If you do not want to calculate the oxidation states, this is a simple way you can figure out if it's reduction or if it's an oxidation reaction. So when the electrons are placed on the left side or on the reactant side of the equation, it is automatically a reduction reaction because you are gaining electrons. Now let's move on. Let's balance the other half reaction. So first let's balance all of the atoms other than hydrogen and oxygen. So you can see we have 2 molecules of chlorine on the right side and just 1 on the left side. So to balance it, we just add 2 on the left. So now we have 2 molecules of chlorine. Since we do not have any hydrogen in this equation, we can go and balance the charges. So each chloride has a charge of -1. So that would mean that the charge on the left side of the equation would be -2 because we have 2 molecules or 2 ions of chloride. And on the other side of the equation, we have an overall charge of 0. So how can we balance the charges? Well, we can add 2 electrons on the right side of the equation. Since the electrons are on the right side of the equation, this means that this reaction is indeed an oxidation reaction because the chemical species is losing an electron. So this is a quick and simple way that you can use to figure out which half reaction is the reduction reaction and which one is the oxidation reaction. However, this method is not always applicable because in some reactions the transfer of electrons is a little bit more complicated, and just from the placement of the electrons in the reaction, it's not enough to determine whether or not it's a reduction or an oxidation reaction. So if you want to be certain, I recommend simply calculating the oxidation number. And the last step is to add the half reactions or to complete the half reactions. So basically you just cancel out things that are on the opposite sides of the equation. In this case we can cancel out the 2 electrons over here and over here. Other than those, there is nothing else that we can cancel out, so let us write down the entire equation, but we just omit the items that we just cancelled out. So that would give us lead oxide plus 2 chlorides and plus 4 hydrogen, the 4 protons, and now we write the other side of the equation. That would be the lead ion plus the chlorine, and lastly the 2 water molecules. So this is our final and combined redox reaction. So this is the method these are the steps that you follow for balancing redox reactions that occur in an acidic medium. Reactions that occur in basic mediums, however, follow different steps, and let's look at that right now. So first, let us find the half reactions of this equation. The first half reaction would be the bismuth hydroxide and the bismuth, while the second half reaction would be SNO2 and SNO3. Now this is the step where you would calculate the oxidation number to find out which reaction is an oxidation reaction or which one is a reduction reaction. However, I will be using the simple method that I just explained before because that's quick and easy. Now let us balance the first half reaction, which is the bismuth hydroxide. The first step is to balance any atom other than oxygen and hydrogen. In this case, we have bismuth, and bismuth is already balanced. We have one on the left side and one on the right side. Now we balance the oxygen atoms. We have 3 molecules of oxygen on the left, and we don't have any on the right. So that means we need to add 3 water molecules onto the right side of the equation. Now let us balance the hydrogen atoms. So we have 3 times 2 is 6. We have 6 hydrogen atoms on the right side of the equation, and we only have 3 on the left side of the equation. So that means that we need to add an additional 3 hydrogen atoms or 3 protons onto the left side of the equation. Now, since this is a reaction that occurs in a basic medium, we need to add 1 hydroxide ion to each proton or each hydrogen ion on both sides of the equation. So, on the left side of this equation, you can see we have 3 hydrogen ions. So that means that we need to add 3 hydroxide ions onto both sides of the equation. Why on both sides, you may ask? Well, that is basically to keep the charges balanced and the atoms balanced. So now we need to combine the hydroxide and the hydrogen ions to form water. So on the left side, we can combine them, we can simplify them to be 3 molecules of water. Now the last step is to balance the charges of both sides of the equation. So you can see on the right side we have a charge of -3, and on the left side we have an overall charge of 0. So that means we need to add 3 electrons onto the left side of the equation to balance the charge. So let us balance the other half reaction. So first we need to check if all of the atoms other than oxygen and hydrogen are balanced. So in this case we have 1 tin molecule on the left side and 1 on the other. So that's balanced. Now the next step is to balance the oxygen. We have 2 molecules of oxygen on the left side and 3 on the right side. So that means we need to add 1 molecule of water onto the left side of the equation. The next step is to balance the hydrogen atoms. So we have 2 on the left side and we have none on the other. So that means we need to add 2 hydrogen atoms onto the right side of the equation. And remember, for each proton we need to add 1 hydroxide ion, and since we have 2 of them, 2 protons, we need to add 2 hydroxide ions, and we need to add these hydroxide ions onto both sides of the equation so that the charges and the mass, the atoms, are balanced. So now we need to combine the hydrogens and the hydroxides together to form water. Now on to the last step, and that is to balance the charges with electrons. So as you can see on the right side of the equation, we have an overall charge of -2, and on the left side of the equation, we have an overall charge of -4. That means that we need to add 2 electrons onto the right side of the equation in order to balance the charge. Now, as you can see in the first half reaction, the electrons are on the left side of the equation. So that means that this is a reaction because we are gaining electrons. And the other half reaction has the electrons on the right side of the equation. So that means that we are losing electrons, hence this is an oxidation reaction. Now the last step is to add the equations together and cancel anything out, such as the electrons and the hydroxides. Right now we cannot cancel anything out. Let's look at the electrons, for instance. We have 3 electrons on one side and 2 on the other. We can't cancel them out. However, we can cancel them out if we get them to be a common number. So what is a common number between 3 and 2? That would be 6. So we multiply the first reaction by 2 and the second reaction by 3. And that will give us these two reactions whose coefficients have now changed. So now we can cancel the electrons out, the hydroxide ions out, these 6 water molecules out, and 6 minus 3 would be 3, so we would have right here 3 water molecules. So now we write the complete reaction down. We have 2 molecules of bismuth hydroxide, 3 SnO2s, and on the other side of the equation we have 2 molecules of, or 2 atoms of bismuth, 3 molecules of SnO3, and 3 molecules of water. And this is the final and complete redox reaction, or redox equation. I hope you all enjoyed this video, and see you next time. Happy learning!